Good afternoon. I'm going to recommend that you subscribe to the channel so you can get the updates, because over the next week, if you have questions for me to answer, I'm going to post a video called Office Hours and answer your question. Whether you're going to be present or not to see the answer is a matter of availability, okay? Because the test is next week, and some people may be, well, everyone's at different paces in studying, so I want to offer you that resource if you want me to solve something for you. So if you want to watch those videos, if you want to benefit from watching one of those office hour videos, you need to subscribe to get the update. I mean, I guess I could let you know, but let's say you want to pop in and watch while I'm doing it live. The subscription will help, okay? I mean, I guess I could send an email every time, but it's so nice to be automated. Hi, everyone. So as promised, today we are going to do problems, or I'm going to answer any outstanding questions about the notes, and then I'm going to solve problems. I did have a student ask me about the NOR section, and to solve some of the questions I didn't solve. Like, most of the pages were solved, but there were a few problems that weren't solved, and some people like a complete set of notes. So I appreciate that. So on pages 7 of the NOR notes, I think she wanted me to solve all of these. I did some of them in the videos, and then I think I stopped here because I think you got the basic idea. I also leave those so that sometimes, so this is the NOR unit and page 7. Sometimes I just pick up and solve the missing pages. So is that okay with everybody? This is page 7. So for the test, it's going to be on, it's going to cover well, I should write them all out because it's not that clear. Oops. So we're going to cover DNS, GDS, NOR. Did I miss one? No, that's it, right? Just the 3, which is really just unit 1, and these are both unit 2. So each test will cover 2 units. And I have enough time to fit it all in. Very good. So in solving this, unless you have questions, any questions? So I do have other classes, and if you get notification of an office hour, make sure you read whether it's stats, finance, or economics, okay? So you don't arrange to watch a video that's not relevant. So even for these videos here, I've been sending notices by email, but if you're subscribed, it'll come immediately to you. And then after the course is done, you can unsubscribe, of course. Or stay subscribed if you want to keep learning and testing yourself. Confirming your understanding. All right, and I really apologize not doing the timestamps. I'm just so burnt out. I haven't been putting in the timestamps. They really are helpful if you want to skim through the notes. If anyone knows how to do the timestamps, you're welcome to put the timestamps in the comments, and I'll cut and paste into the description if somebody has time for that or is interested. That would be helpful for everyone. Okay, so no other questions. All right, let me solve these. So these were at the very beginning of the NOR unit. And you're supposed to apply the property. Okay, I gotta make this bigger, right? Because you can't see this. You're supposed to apply the 68.95 99.7% rule to solve these problems, and not use anything else. The idea of these exercises was to make you understand the deficiencies of using only this rule. So if I use this for this problem, is that correct? Let me double check that's what I did here. Yeah. So for this problem where x was known to be normally distributed with a mean of 64 and a standard deviation of 2, we should draw it. So we sketch it. You should practice sketching. If you're having trouble with that, let me know. So 64 will be in the middle. Now, I am currently drawing this distribution. However, once I teach you, or once you learn about the standard normal distribution, only sketch Z, okay? Don't go on sketching X, because you're gonna get confused about what to do. I know there's some students that learn this 68, 95, 99% rule very well, and then they just kind of stop learning. Okay, that's just going to give you the answer to a few questions. Okay, it's not going to help you answer any question on this infinite number line here. Okay, so these are little x's here, and it's an infinite number line. Mind you, it's less likely that there's stuff out here and way out here, but anyway, it's still an infinite number line. So let's sketch the rule. So if I add 2 on each side, I'm going to get 1 standard deviation from the mean. And the 1 standard deviation is where the curve starts to turn up. Okay, I did explain that in the videos. So that would be, in here is 2. So this has to be 66, and this one has to be 62. If you notice the video is buffering, let me know. I noticed in some other videos it did buffer. So just let me know. Okay, so that's for 2. So we're going to add another 2 for 2 standard deviations, and that's going to be an equal distance away. So that would be 68. And then over on this side it would be 60. And then one more would be, I'll move this away. One more would be 70. All right, and then what I see, these are all I know are from using this rule, I just know areas or density in between these large tick marks here. But I don't know anything else. I can approximate, but by far it's not going to be precise, okay? So in this question, I want less than 70. So that's going to be the area, all this. Now I can extend that line if that bothers you, that this doesn't hit, but this goes on, right? And this one goes on. So I know that that's 3 standard deviations. And 3 standard deviations from the mean on both sides is 99.7%. In between, I think someone just wrote that they're having trouble getting in. Let me see. I closed my email. 1 minute. One moment, sorry. I should. So is it possible some of you are not getting my emails from, I'm sending emails from the registrar, from the system where I put grades. So only the students who are enrolled in the course will get the emails, and if students have recently dropped the course, they're not going to get the email. So I use that system. I'm not comfortable yet with Outlook. I should figure out how to use Gmail again. But anyways, the email situation is very challenging. So I don't know if I get messages that people are not getting my email. Please let me know if you're missing any emails. I don't know how you'll know that if you're missing them, but if you've had the experience where you miss emails, please write me about it, okay? So back to what I was doing. So between here and here, and I need to get, notice I need to get all of this. I want all this, all the way. Not just 99.7 in between, but I can use that to help me find the answer. So between 3 standard deviations is 99.7% of the observations, or R, so 99.7% of the observations. Outside of that is 0.15% and 0.15%. Okay, so if I want to go to the left, what I'm interested in is everything here and here. Okay, so people will do this differently, how they do this. I mean, I'm sketching it, it's just one technique. You can remember how it works, or but I need to see it if I'm going to grade it, okay? So on the test, although you're going to give me final answers, I will accept your handwritten work. You will be able to submit it to me. So I could give you potentially part marks. So if you don't write something, I can't give you anything, right? There's no hope. So if you sketch this, that will help. So everyone follows then, I would add these two together, and the answer to this question would be 99.85%. So let me write that. I have to write it somewhere. I'm trying to think of where to write it. Okay, let me move this over if I can. Can't. I haven't figured out how this is dividing things yet. This software works like Photoshop. Anyway, wherever that adds up to. Okay, I'll put it here. There. Can you see that? That's the answer. Yeah, the exam will be in Moodle. Yeah, very strange that you don't get my emails if you don't get them. I don't know. Anyway, just keep me posted on the email situation. Check your spam and let me know if you found emails in there too. All right, so people who came late and don't know what I'm doing, I'm just solving these from, I don't really want to spend too much time on this because this is going to be very small amount of your test. I mean, even I asked this question, but basically this is just applying the 68, 95, 99.7% rule. So what I'm going to do, I'll just put the answers here and I won't solve them. And if you have problems getting the answer, you can let me know, okay? And I can solve them somewhere else. But right now, I don't want to spend too much time because a half an hour is already gone practically. Just quickly looking at the next few just for the answers. This one will be, this next one will be 1 minus the complement or the opposite. If I want to get greater than 70, I gotta go this way. So it's just 1 minus what we got before. So this would be 1 minus 0.9985, and the answer would be 0.0015. So that's the answer there. For the next problem, see it? I don't know. I'm going to make this smaller. Let me see if I can group them again. I'm playing around with this. I don't know why. No, I can't move it. Okay, for this one, can you see it? This question here is the same question as this one. Why? Because X is a continuous distribution, and for continuous distributions, what's the difference between 5 and 6? for this one, that's greater than 70, and this one, it's greater than 70 plus x is equal to 70. That's what that symbol means. But since for a continuous distribution, this is going to be just 0, there's no density at a point, only in a range of values. That means that those two results are the same. Any questions? Very good. No. Some things are staying. Any questions about what I just did? So for the next one, I'm going to continue drawing. I'm going to draw in black. So I want the area, so this says, when I see this and the number between, and it's you know, between a smaller number, so it's like in order. Okay, when it goes in order, in order. Does anybody have trouble seeing these colors? Maybe I'll put it in a different. So when they are in order and you see this symbol, the way you read this is the same as saying between. So you want the area between Gabrielle, you're asking about this thing above here? So there's, in a continuous distribution, there's no area or density. There's no P is probability, proportion of observations, the percentage of observations, or the probability. These all mean the same thing. And there's no density or proportion, percentage, or probability at a single value for a continuous distribution. It has to be a range of values. So you need to know that. I did say it in a video, I'm pretty sure. Can someone confirm for me? I did teach that in one of the pre-recorded ones. So, as we had, I'm going to continue in black. So 64 is in the middle. 62 is one standard deviation away, because the standard deviation is 2. So to figure out this area, from the rule, you know only that between here and here is 68% of the possible outcomes. %of the possible outcomes, but I want between 62 and 64, so I can figure out with this simple rule as long as the distribution given is normal, and I know the standard deviation and I know the mean, I can rely on this distribution to solve problems at the position or between positions of 3, 2, or 1 standard deviations from the mean in either direction. All right, so to figure this out, it's just 68 divided by 2. If you do it another way and get the same answer, I'm happy. So this ends up being 34%, or you can write that as 0.3400. Questions? So if you feel like you're behind or you didn't see this or what's going on, just watch the first few videos where I cover this. So this is everything before I get into introducing the standard normal distribution. The last one, as I just said, this will always be 0. There's no density at a point. So whenever it's equal for a continuous distribution, I'll just say at a single value. Only for a range of values. Okay, take a screenshot if you need to. I'm going to move on. All right, then there's 4 more problems, and the emphasis of, well, the first one is to introduce you to solving a backward problem. And the last 3 are to motivate the need for the standard normal distribution. So this is a backward type problem where, okay, initially the problems before were what I called type 1 do I say X type 1 or type 1? Oh, now I'm going to remember. Let me see what sorry. I want to see where I write Z type. Okay. So this is an X type 1 problem. That's what I was doing before, where you find the probability given values of X. And then there's the X type 2 problems, which is what we're going to do now. Given a probability, find X. It's backwards. So probability or percentage or proportion. So this is backwards. I give you a probability and you have to find x. I'm still going to sketch this. I'm going to sketch this. Now the way I've written it, this means the curve, and this means value of x along the curve. Okay. So this is saying to the area left of x is 97.5%. So that means I have to be here. And what I want to find is what x is to put me there. And to this point, using only this tool, can you do it? That's the question. Can you pull it off? So what we're looking for is 0.975. Okay, yeah. So Fabiola, you're using the standard normal approach. Oh no, well I guess you're kind of doing the thing. Okay. So without doing that way, just using the drawing. Okay, this is elementary, using the drawing alone. So I'm going to redraw this here with 64, 66, 68, and 70. Can you see that? And this way, 62, 60, and 58. Where is 9750? Where would I see that? Could I see that? Let's just chop it up. Let's cut it up. If I was to go between two standard deviations, I would have 95%. Outside of 95, outside of there, this way and this way would be 2.5 on each side. Does everybody agree? So I'm going to erase this because I don't need that. So there's 95% between and 2.5% on each side. you can see that if you add these together, what do you get? Okay, using the rule, only have 95% between 68 and 60. We need 97. So what does the answer have to be? I want the area to the left of a value that makes 97.5. So that's going to be, so like I said, I'm not going to ask you to do this on a test, okay? This is just, you need to know the mechanics, you need to know the gymnastics around working with the rule. I'm not going to ask you many questions, but it's assumed you know how to do that. I'm not going to, really, the test is not going to depend on this. The test is going to be the other stuff with the standard normal curve, okay? But it's assumed you know how to do this. But I don't want to spend more time on this. All I'm going to say is, that's how you get that one. The answer then is an X. The answer is X equals 68. It's going to be 68 that gives you that answer. But you feel uncomfortable about it because it's not a systematic approach. It looks like I'm doing things differently for every problem. There's no systematic approach, and that's why we turn to the standard normal. As well, we can't get exact values of a problem in a problem like number 10, or in a problem like number 11, or in a problem like number 12. Okay, so I have these asterisks here to make the point that you're not going to get an exact result. And this is why we need the standard normal curve. It should be precise. Okay? Gabrielle, I'm using this. I don't know if you saw the videos, but I'm using this rule. That's the rule that you learn as the hallmark of of normal distributions. All normal distributions have one standard deviation from the mean, 68% of the observations, 2 standard deviations from the mean, 95%, and 3 standard deviations, 99.7%. As I explained, it's assumed you watched all the videos. If you didn't watch all the videos, this is obviously going to be confusing. The idea of this course is you watch all the videos and then you come with the questions. Okay, so you got to catch up on the videos, or maybe you just missed one, because this is very brief. I don't spend too much time on this. The values are coming. The values on the bottom are coming from the fact that at the beginning of the question, X is given as a normal distribution with a mean of 64 and a standard deviation of 2. That's how I'm drawing that. Because I'm told it's normal, so I know that this rule applies. I'm going to cover my palette. Find it distracting. Okay. Questions? So, we spent 45 minutes. If you need more time to review that, then do so. But really, I'm really interested in working with the standard normal density, and that's what I get into. And I describe how you use it. So the next question, some people emailed me questions. Let me have a look. I just looked at, okay, I'm just checking my emails. Okay, so if you've tried the quiz problems, those are the online quiz problems. They're rather challenging. You should be able to do them, okay? You should be able to do them, but I agree they're challenging. So I can, I'm going to solve one of them. Let me see if there's a simpler problem first. Hold on. Okay, does anybody else have a question? Otherwise, I'm going to do the quiz 2 problem. Okay, let's look at number 7 of the homework. Number 7. Which homework? Nor, Fabiola? Okay, so Nor. Sorry about that. Okay, so let me do this Nor problem. And someone asked me, Edgar asked me, variance refers to, so I have that variance. The square root of it is the standard deviation. Right? Or you could say the standard deviation squared is the variance. So there's different symbols I have for that, and there's different for population and for the sample. It's the same relationship between standard deviation and variance. So you could have the sample one right? Or you could have the population one. Or you could have the other way around, of course. Okay. So yeah, I don't have a symbol for variance. I have a symbol for standard deviation. So standard deviation squared is the variance. Nice and confusing if you don't get it. But if you get it, it's obvious. Okay, so now we're going to do the homework number 7. The question is NOR 7. It tells you, I'm going to transcribe the important information. The heights of students at a college. So X is height of students at a college are normally distributed, and X is normally distributed with a mean of 68.4 and a standard deviation of 2.7 in inches. That's the information. The question is, if you take a random sample of size 1,000, what's the chance, how many of them would you expect to have heights less than 63? So the chance or probability that a student is less than 63 is what I want to find. And then once I get that, that would be the chance per student, right? Or the probability per student. So now this is after learning about the standard normal distribution. So how you solve that once you set it up. So maybe the setup and knowing where you're headed is the challenge here, because I have to challenge you. This is known as what I call an X type 1 problem, where I give you the X, the little x here, and you find the probability. But I'm going to use this using the standard normal distribution is going to help save a lot of time. So how do I use the standard normal distribution? You transform the X into a Z using this relationship. What Z is, Z in words, oh, you can't see that. Is defined as the number of standard deviations from the mean. That's a new variable, like a new unit, a new metric. So that's what I do. Oh, I'm learning how to, interesting. Sorry, I'm learning my new iPad. Okay. And the Apple Pencil. So I take this and I standardize. I turn X into Z. I minus, and now if you watch the videos, you'll see how and why I do that, or why I do that. I explain why I do that. This is known as standardizing. What is the answer? So you guys can solve that for me. All right, consensus. This is -2. So even though you roughly know the answer to this question, let's be precise. Let's use the standard normal table, and let's also draw it. So there's full communication. And if necessary, you get some part marks. So -2 would be over here, and I want to go this way. So that's what I want for a z. I use lowercase, where this is z, the curve. So if you look that up on your table, so what we did was we went from an x-type problem, and I converted it into a z-type problem. That was the approach. Because solving this problem using the 68, 95, 99.7% rule actually would have been able to do it, because it ended up at -2. So we actually were 2 standard deviations below the mean. However, I'm starting to teach you not to use this to start practicing with the z. Okay? So it doesn't have to be exactly 2 or 3 or 1 standard deviation away. So basically, I convert so I can use the table. And notice I didn't draw the x curve. I drew the z distribution. All right, so what you do is go to -2 on the table, on the negative table, and you find it's 0.0228. Or you could say that's 2.28%. Am I finished? Did I answer the question? So you always ask yourself that before you choose an option. So my suggestions, if you're doing the multiple choice problems, don't look at the options. Completely solve the question, answer the question, and then look at your options. So go back and read, what was the question? The question asked, how many students would you expect to have heights less than? So how do I finish? How do I get the right answer? So this is 0.0228 per student, or put this over 3 decimal places, right? Multiply by 1,000 to 2.8 per 1,000 students. That's how you use the probability. Very good. Okay, so that's not straightforward. Now you know. So now you have to pick among the options. So 2.8, which should be your options are. Oh, did I make a mistake? Did I do enough? 1, 2, 3. What did I do wrong? Oh yeah, no, I did it right. The answer is, so it's tricky, right? The answer should be E. You round it up. Well, out of the options are A was 997, B was 477. No, it's 977. C was 228. You see how they mess with you with these options? You can see how many ways you could have gone wrong here. And then 23. The best answer for those options is 23. And you can't see that? There you go, sorry. It's hard to fit everything on. Keep track. I don't know what happened. There you go. All right, so take a screenshot and go back to this later. What else? Okay, what other question? What was I gonna do? I was gonna do I was gonna do some midterm problems. Yeah, Fabiola, I know that was tricky, but now you know, right? If that's how you use the probability. If it represents per student, then you can adjust it to however many students are in your sample. All right, I was gonna do the quiz problem. So I guess I'm giving you the answer if you haven't done the quiz problem. I'm just getting the question. Okay, so the question, where's the question? Is for the normal distribution, I'm paraphrasing. So what is the percentage of outliers in the normal distribution if you apply this rule, as opposed to for symmetric distributions, we say at 3 standard deviations, if this distribution is normal, then we establish that there's 0.15% and 0.15%, so for 0.15% below as outliers on the lower end or lower tail, and there's 0.15% or 0.15% on the upper tail, or a total of 0.3% outliers total. So for instance, if the sample size, I'm going to use big N, if the sample, not the sample size, if the, too many N's, right? If the population size is 10,000, that means how many would be outliers? Now that's if it's perfectly normally distributed with the properties of a standard normal or any normal curve. Right, Hector, 15 on each side. Yes, you can refresh the video if it gets blurry. Just refresh the page. If things freeze up or look blurry, refresh the page. So that's using the rule for symmetric distributions. Right? Because outside of 3 standard deviations are called outliers for symmetric distributions. And the normal distribution is a symmetric distribution, so that's the rule I should use. But how about if I use the other rule? Am I going to get more or less outliers? Now remember, outliers is supposed to be extreme. It's not supposed to be common. And that's why, it's such a small amount, 30 out of 10,000, it's bizarre, it's unusual, it's not common. That's why we call it outliers. So let's see, what happens if we use the wrong rule? Let's use the other rule. So first of all, x is normal. Just going to check if it's for the standard norm or normal. It doesn't really matter. Okay. Jasmine, did it say normal or standard normal? It really doesn't matter because the percentages stay the same. Yeah, check for me so I can, it doesn't exactly matter. I just want to be, precise with this. Because the percentages are the same for distance between mean and 1, 2, and 3 standard deviations from the mean. Okay, so I want the IQR first. The IQR is the 75th percentile. Let me write it in words. Minus the 25th percentile. That means distributed as okay. So it's just normal. So let's continue. So I want the 75th percentile and the 25th percentile. So let's just look at this. Where should I be so that 75% is to the left? That's what I have to get the 75th percentile. I need the position and for the 25th percentile, I need similarly, I need the position so find those two for me. So this one we'll call Q3, and this one we'll call Q1. Okay, Hector, does everybody get that? That Q3 would be 0.675. So you have to, this is a backward problem. You look inside of the table and try and find 7500. And when you do that, you find it's between two values, and so this one is 0.675. And then because of symmetry, or you can look this up, and you will find on the left side, because of symmetry, it's going to be negative 0.675. Everybody with me so far? Next, you subtract them. So you subtract them, you're going to take 0.675 minus negative 0.675. In other words, it's just two of those. So you want the area in between in a symmetric distribution, not the area, but you want the range. It's the interquartile range. So it ends up being just 2 times 0.675. Is 1.35. What do I do with this number? So this is, this is a synthesizing problem. I'm using the wrong rule, the IQR rule that's used for skewed distributions. I'm applying it to symmetric distributions to kind of help you understand why we have different rules for symmetric and skewed distributions. Yeah, that's where we're headed. I'm going to contrast them by using one rule in the wrong place and see what we get for outliers. Are you with me so far? What do I do next? So everybody's with me so far? You know what I did here? You get it so far? I didn't type anything. All I did was put the negative of that. I'm waiting for you guys to tell me what I do next. So you take that's the IQR. And then we're supposed to identify outliers on the left side. It should be smaller than Q1 minus 1.5 times IQR. And on the right side, it should be greater than Q3 plus 1.5 times IQR. So tell me what the limits would be. And this is in terms of standard deviations from the mean. So it applies to any normal distribution. It doesn't matter. So like, if people, okay, so those guys are getting it, some people are getting it, so if I do this, Q1 is negative 0.675 minus, I should do this calculation, so 1.5 times IQR is equal to 1.5 times 1.35 from here, and then that's multiplied. This is a long problem, but you just repeat the same thing on both sides. You have to be consistent. It's long because you duplicate. You do the same thing twice. So 1.5 times 1.35 gives you 2.025. So that is this. So I'm going to subtract that from Q1, comma, and then I'm going to add it to Q3. And if you don't know what I'm doing, it's because you didn't practice the 1.5 times IQR rule, but you should be familiar with this if you've seen the videos. So now I'm going to subtract 0.675 minus 2.025, and I get negative 2.7, and it should be symmetric, right? Because I have a symmetric distribution. 2.7. So the final, have we answered the question yet? The final step is to find the probability between, outside. But already you see this is larger or let's say greater amount of outliers or more in the tails Okay, there's more in the tails than for symmetric distributions, right? Because this is a smaller range. It's smaller than negative 3 to 3. So all of this problem was solved for the standard normal because I could apply this to any normal distribution. And this says outside of 2.7 standard deviations from the mean. Right. So the conclusion is, when you check this, when you check at negative 2.7, you find the probability of being there what's the percentage of observations out here? So that's a lot, right? It's very different. So because of that, it's going to be the same on the other side, right? Because this is a symmetric distribution. It's going to be the same over here for 2.7. I'll put it as a percentage. Oh, I guess it doesn't matter. There's a percentage of outliers. Okay, so it's 0.0035 times 2, which is 0.007. So if you use this rule, it's telling you you have 0.7% outliers. But if you're using the rule for symmetric distributions, you find 0.3% outliers. So it's too many. That's why we stick with a special rule. Okay, so the hard part was knowing where to start with this, but then I think yeah, I think it's okay once you get going, but you need to know where to start. The start was to find the number of standard deviations where the Q1 and Q3 were, and going from there. So overall, we made a distribution we found Q1 at negative, we found Q1 at negative 0.675 and positive 0.675. This was Q1, and this is Q3. So, and this was for the standard normal. And then what we did was we created 1.5 times IQR rule by adding 1.5 times IQR to Q3, and we subtracted 1.5 times IQR from Q1, and you ended up back here and over here. So this was negative 2.7, this was positive 2.7, and you found the number of outliers, percentage of outliers here. That's what we did. That's the overview. All right. So 7:30. What next? Would you like me to solve problems in the midterms? Yeah, this was a problem from quiz. Yeah, this is a quiz problem. Okay, no comments? So I'm going to just go into, pull up an old midterm. I'm going to verify that this is in the sample midterms. And meanwhile, you guys work on that problem. Okay, so this is question number, no. No, that's not it. I'm just checking that it's not, this is available in the midterms that I gave you already. If you have any problems from those midterms, let me know. Okay, so I am in what's the last one, October 28th and November 2nd. So this is from October. This is in the midterm or term tests. Under term tests, this is the last one that's called October 28, midterm exam, October 28 and November 2nd. So what's the answer here? This is question number 3. So without looking at the answers, what are you guys telling me here? Some of you are saying, okay, C and A. Okay, so very good. So I hope you didn't look at the answers. But the answer is A. So what is deviation? What does the standard deviation measure? It's the square root of the average square deviations from the mean, right? So standard deviation is the square root of the variance, which is the square root of the average of the squared deviations from the mean. So the more observations that are far away from the mean, the larger the variance and the larger the standard deviation. So this one is showing most of the values are near the mean or the balancing point of the distribution, and there's just a few out here. That's in contrast to the other ones where you have a lot out here, and this one has level all the way across. And the balancing point of this one, D, will be like, I don't know, You know, you have to balance these things out. I'm not even sure, but it's not, it's pulled towards more toward, not to be precise, but somewhere in the middle there is a balancing point. No, that's too far away. I think it's more, maybe. So the point is that you have, you know, increasing number of observations. Remember, the height is the number, right, or percentage. If there's a lot that are far away, that's going to make the standard deviation higher. And then even here, and this one below, same deal. Well, that didn't work. I'm gonna make it a little bit smaller here. Let's see if I can do this. All right. Questions? All right, should I keep going? Did anybody have any particular questions on this test? Did anybody do this test already? Did anybody practice this test already? So Winnipeg is where I'm from in Canada. So you'll read about Winnipeg and how cold it is, or it can be. Try this one, number 4. Oops. So we have almost an hour left. Let's just do some problems. And for those who still have to watch the videos, watch them and then you can watch these later, okay? Try and catch up with your notes. And you can watch these ones later. Okay, so where do I start with this problem? What are you doing? What is your approach? How did you get that? The first thing you want to do when you calculate a median is rank these. So put them in order. So the numbers are in order: 14 is the smallest, then 15, and then 2 18s, and then 21 and 23, and then there's an unknown one. So the question is, what should that unknown one be if you know the median is 18? So n equals 7. So that means that the fourth observation is the median. Right? Because the median is found at this observation. So that's 8 divided by 2 is 4. So you're told that the median is 18, so you have some options. So either Friday's temperature could be in there, which would make it the median, let me see if I right, because this has to be, this is the ranks, and 18 has to be the median. So if it's in here, then Friday has to be 18, because that would be the median. Because that's where the median is, right in the middle, the fourth observation. However, what's the other alternative? Could Friday be here? Or could Friday be here? So first one. Could Friday be here? Like somewhere in between? If it is some number in between, the median could still be 18. Right? Because there would just be one more value here, and then you could still get this one as the median. So you'd still have 18. So it could be anything between 15 and 18, so that's true. What about here, above 18? Could it be above 18? Could it be anywhere between 18 and 21? And still have a median of 18? Yes, it could, because then this would be the median. So what's the answer? It could be between 15 and 18, but couldn't it also be over here? That would still let 18 be the median. Any of those values would. And same for here, on this side, on the right side. If it was anywhere in there, the median could still be 18. All right, so what is the answer? Am I convincing you? Okay, so you guys see that it's E. It could be anything in any of those ranges or anything beyond those ranges. So this is not the rule here is to understand how to get the median from these values and incorporate a new, other value. Because you have those two 18s in the center, it makes it possible that Friday could be any value, 18 or otherwise. All right, should we do another one? Let's do number 5. Okay, you try it and then we will look at it together. Okay, I'm back. So a mean GPA in a class of 14 is 3.12. One student whose GPA is 2.41 drops the class. Two new students whose GPAs are 3.97 and 4.26 join the class. What's the new mean GPA? Okay, so a weak student left the class and two good students joined the class, all likely increasing the GPA. But you have several to choose from, so we need to be precise. So I'm going to use the fact that the mean uh-oh, my pen has no power. Okay, I got to use something else. Just gonna charge it. Okay, let me use my, what is wrong with this thing? It's frozen. Not that one, it's for the mean, right? So what's the mean? The mean formula is, hold on, I don't have, for some reason, my pen doesn't work. Let me try, okay. Let me try, okay. So the mean is this, where you take the total sum and you divide by how many there are. Does that make it easier for you? So it turns out what I really want is this. Because that's what I'm going to manipulate. I'm going to subtract so that's what I need to calculate, right? Because I'm going to take this guy off and I'm going to add these two in and then get a new total with one extra student. I already know this and I know this, so I can find the total. So do that for people who don't have the answer yet. Make that calculation. So you're going to take 3.12 is equal to the total divided by 4. You see? So the total must be, make the multiplication, multiply these two together. This is algebra. If you have an algebra problem, let me know. But for this, I'm going to find the total by 3.12 times 4. So that makes the total 12.48. Now, I'm going to manipulate the total. I'm going to subtract this, I'm going to add this, and then calculate the new mean. What do you get? Did I make a... Oh, 14, not 4. Thank you for catching that. So 14, not 4. Do that again. So 14, I read 4. So one more time, 3.12, see, get to test you, times 14 is 43.68. Now what? Now subtract 2.41 and add in those 2 new students. And what's the new total? Right. I'm running out of space, but I'll make the calculation here. So now the new total, can you see that? Yeah. New total is 43.68, subtract off 2.41, but add in 3.97 plus 4.26, and you get 49.5. And what do you do next? Are we finished? What do you do last? Now there's going to be from 14 minus 1 student plus 2 students is just 1 more student. So that's your new n. So you have your new n, your new total. So I just keep, so you see these problems are complex. They seem complex, like why am I repeating the same things? I'm doing the same things, but multiple times. So twice I had to use this, the formula for the mean, and I used it backwards. So your final answer is 3.3, is it? So the answer is B. How many people got it? So some people, Jasmine got it, Jorge got it, Hector got it. Very good. So it did go up, but you don't know how much it went unless you did those calculations. Would you like me to continue? We have a half an hour left. Looking through the exam, are there any specific problems you want me to do? Notice anything on the correlation. Correlation is not on this test, okay? You don't have to worry about that for this test. I can ask you about scatter plots, but not, I can't ask you about like calculating R, because we didn't cover that yet. That will be the subject of next week. let's see, do I have problems? Oh, not a lot of, not really any questions on DNS. Let me see at the end. Oh yeah, it's at the end. At the end. All right, let's do these, unless you guys have something else you want me to do. DNS, GDS, and NOR are on the test. So for 22, in order to gauge players' opinions about suggested rule changes, the National Hockey League Players Association randomly selects 10 of the league's 30 teams. From each of these 10 selected teams, 5 players are randomly chosen to complete a survey. The sample of 150 players is what? What kind of sample? Anyone want to guess? You guys are good. You learned with our discussion of multi-stage. Very good. Because we start at the level of the teams, and then we go to the level of the players in the teams. So we go deeper and deeper, closer to the players. Anyway, it's a simple one because there's only two. But we're able to list all the hockey teams, and we're able to list all the players in those hockey teams. So that's a multi-stage. Very good. Next one. Question 23. This is directly off the definition. Do you know the definition? Gabrielle, I don't see really the difference between the applications. It's still going to be the same thing. I've got to work with the pen. But thanks for the suggestion. Well, you're going to have to look at your notes. This is the definition in the notes. Okay, so you guys are not picking the right answer, but you're going around the standard understanding of what a simple random sample is. Every individual in the population has a known chance of being selected into the sample. That was A. Every individual in the population has an equal chance of being selected into the sample. Very interesting. In fact, the answer is C. Every group of n individual has an equal chance of being selected into the sample. So it's really about the samples. From all possible samples of size n, each possible sample has equal chance of being selected. So you guys got to read that carefully. It's in the unit DNS. I think this is, so if I look at my definition that I have on page 17 of the notes, I'm going to copy it into the chat. Oh, won't let me. Too many words. All right. A simple random sample is a procedure used to select a sample of n objects from a population in such a way that each member of the population is chosen strictly by chance. The selection of one member does not influence the selection of any other member. Each member of the population is equally likely to be chosen, and every possible sample of a given size n has the same chance of selection. So that's your best answer. C. So we don't necessarily, right? We don't, for A, when you think about it, remember, we can get a simple random sample from a bunch of volunteers. Now, those volunteers come from a population. I don't necessarily know the size of the population, and I can't label everybody in the population. So this just is not true. Okay, or let me cross it out there. Every individual in the population has an equal chance of being selected into the sample. No. Remember, I don't have necessarily the population. I just have a list of volunteers and I label them. So whatever I have, I label and then I choose from there. That's not necessarily the entire population. It's just, I know, it's just a group. Just some possible members of the population. From there, I create a simple random sample. So keep that in mind. Right? So, like, I take a list of volunteers. It does say each member of the population is equally likely to be chosen. But that's the best answer. Okay, I'm going to keep going. Let's try the next one. Okay, which of the following statements is false? A voluntary response sample, one second. A voluntary response sample is not reliable as individuals who feel strongly about the issue are overrepresented. This is actually true. Undercoverage occurs when some individuals in the population have no chance of being selected into the sample. True. In multi-stage sampling, individuals in the population don't always have the same chance to be selected into the sample. That's true, right? Because your chances of being selected change as each stage progresses. So we'll say this is true. Non-response is a frequent source of bias in telephone surveys. True. A convenience sample is reliable as long as the sample size is large. False. So that's easy. Well, for people who didn't get it, sorry. Okay, so E. So that's how I deal with truth and false. I answer them all. I address them all so I don't forget. I'm looking for the false one. Let's do some normal problems before we go. Let's solve some normal problems. Oh yeah, these were with blocks and all of this. Okay, so if you have any questions about these factors and blocks, try those and let me know if you have questions, okay? I want to do some normal ones. Oh, there's lots of questions here on blocks. Okay. Very interesting, this problem. So you can have fun with that. All right, let's see. Let's try 33. Okay, very good. So you guys got it's B, because what you look at is the standard deviation. And you remember my demonstration in the video about the fact that for normal distribution with the same scale, if I narrow this has to be 68% between here and here, if this is one standard deviation away. So if I make the standard deviation of the first one bigger than the standard deviation of the second one, it forces because it's still 68%, but let's say this is one standard deviation. Oh, I'm gonna get it out of the way. this area here has to be the same if I narrow let's do this again. I'll make it lower. I think, do you get what I'm getting at here? So if I go one standard deviation away from the mean, but it's smaller, this is smaller, and it's spread, this has to have the same area, so it's going to have to be taller. That's the point. Because this has to be 68%. And that has to be, the green areas have to match. All right? You can read that. All right, next one. So these two problems are just applying general properties of the normal distribution. Okay, you guys are good at this. So 34, does anybody need me to show you that then? 34 is A. You're going to go to the next one? So if you have to go, you guys can leave. I'll say goodnight. Otherwise, I'm going to stay and I'll solve these three problems and then I'm going to go too. All right, so if you want to stay back, you're welcome to stay. Have a good night, Elena. Is it Ileana or Elena? Good night. Okay, so let's see. What proportion of gymnasts receive a score between 8.2 and 8.7 on the uneven bars? So I go to the uneven bars here. And I have the information on the means and standard deviations for each of the events. I want to calculate the probability or the proportion that are between, so I write between like this. So this is a type 1 problem, is an X type 1 problem. I have to standardize to solve it. So I take 8.2 and I standardize with the mean and standard deviation, turning X into Z, and then using my table. So that puts me between, to always write smallest to bigger, smaller to bigger. Gonna just move these over. From negative 0.8 to 0.2. And then I draw this. Now some of you are just going to go in the table, but I prefer that you draw this between negative 0.8 and 0.2, which would be closer to here. And I want this area in between. I look on the table, which gives me the percentiles. And what do I get? Oh, I don't have the table in this test. Tell me what I get. It looks like the stream was not healthy. It kept on breaking. I have a list of, oh, I'm sorry if it's buffering. Don't know why. Did you look it up? If you look up on the Z table or you use Excel, Nobody's there to get it for me. So when you look this up, you get, I'm going to trust Shariat, 0.2 for this to the left here is 0.2119, so 21%, and to the left here it's 57.93. And I showed you to take the big minus the small to find the area in between. And that gives you the result. $3,674. Everyone agree? So that's for question 35. B is the right answer. Okay, next one, unless you have questions. For the next one, the top 6% of gymnasts in each event earn a trip to the national championships. What minimum vault score is required to make it to the nationals? So right away, this is a backward problem because I get a percentage and I'm asked for the score. So I know I have to do this backwards, and I begin with the Z drawing and I say, I want to know where this is to have 6% here. If I have 6% here to the left, that means I have 0.9400 on the left. So each position, you can look at it from being on the right, 6%, and on the left, the complement, in this case, 94%. Because one is 1 minus the other. Or each is 1 minus the other. So with that 94%, you look inside the table for that number. Do things backwards. What is the Z? So it should be a positive number. 1.555 hectare. So when you go to 0.94, do I need to show the table, or you guys know how to do this? You look inside the table for that number. Let me add. Nope. So 0.94 It's 8.2, that's not possible. Oh, okay, no, but at 0.94, what is the z? What is the z associated with 0.94? Yeah, you should really print the tables, or you're not going to be able to do this on a test. So you need to print your notes out. Print the tables at the very least. Or you can go to Excel, if you know how to use Excel. Let me see if I can use Excel for this. Can you see that? It's not working. I want to use a function. I have to choose it. Normal. I believe it's nor. And I want to do the inverse. And I just have to put the probability here. So that's how I would use. Let's see. So I put in there the probability, which was 0.940, right? So you guys can use this on your test. You don't have to use the tables, but you should know how to use both. If that makes any sense. That's how it works. Oops. And there you get it. 1.55. And rounding it to 3 decimal places, 1.555. So the code for that was norm.s, so that's standard normal inverse. So I'm doing the backward or inverse problem. Okay, you guys are good. So going back to the problem, I'm going to say z is equal to 1.555. And then that was step 1. I call that step 1. And then step 2 is x equals z standard deviations from the mean, and I fill it all in. So z standard deviations from the mean. And the answer is so I'm converting from the z, I'm unstandardizing and getting the score in terms of the units of the problem. So if I'm 1.55 standard deviations from the mean, I have to fix that so that in terms of the problem, I get a different answer than all of you guys. Why? 8.6. Let me do that again. So what did you guys do wrong? Or what did I do wrong? One 1.555 times 0.5 plus 8.6. Oh, volt. I used the wrong one. Okay, I circled the wrong. I need to go to the volt. So I'm going to use the volt results, and I have to fix this because I used the wrong results. So the volt, well, that's right. What's wrong is these numbers that I put here. I need to put, for the volt, it's 0.4. And for the mean, it's 8.2. Right. I used the wrong elements. So correcting that, you get this answer. Okay? Let's do the last one and then that's it. One more. Julie receives a score of 9 on the balance beam, 9.2 on the uneven bars, and 9.1 on the vault, and 9.3 on floor. In which event did Julie do the best relative to the other gymnasts? So how do we solve this one? You're still wondering what I did there. I made a mistake. I used the wrong mu and standard deviation. Okay, so for what's the technique to solve this problem? Right, standardize. Standardize each result. So for the balance beam, let's do them right here. So she got 9. On uneven bars, 9.2. The vault, 9.1. And floor exercises, 9.3. So standardize each one, where this is the mean and this is the standard deviation above. These are Z. So for this one, I'm going to make it bigger. So it's going to be 9 minus 8.3 divided by 0.3. And for this one, it's going to be 9.2 minus 8.6 divided by 0.5. So you see they're all different in their mean and their standard deviation. One with high mean also has a high standard deviation. So when you adjust them to standard deviations, you're not sure until you adjust them to know how to compare them. You have to standardize them. So this one is 9.1 minus 8.2 divided by 0.4. And the last one is 9.3 minus 9.0 divided by 0.2. So which one is the best? So clearly the best one is A. All right? So the answer is A. Okay, so I'm going to let you go now. Just keep in touch with me if you want me to solve any other problems. And I can do that over this week. Okay, because next week at this time, well, at 6 o'clock, I'm going to post the test and you have 1.5 hours to complete it. And then we're going to get together, either talk about the test or just do the new material. Start the new material. Okay? Any questions? Jorge wrote something. You don't have to get the percentages, Jorge. This is good enough. You can stop here. You have the answer because the standard deviations from the mean are going to be ranked in the same order as the percentile. So we're done. So she performs on the balance means 2.33 standard deviations from the mean. She's not an outlier, but she's really, she's above, yes, she's in the 99th percentile if you calculated that right. Yes, she's way up there. Yeah, you're right, 99%, I just checked. The test is gonna be, I think, multiple choice. I'm not sure yet. I might have one question you have to solve with your, as a short answer question. But essentially, they're multiple choice, but I'm gonna allow you to send me your handwritten work for part marks. Okay? Give you guys a break. Well, you still have a week. Still have a week, and just keep in touch of where you need any help. But watch the videos, work with pen and paper, keep a record of what you don't understand, and you'll start to see there's a pattern in what you don't get. It's not possible that you don't know anything. Okay, it's just a matter of grouping together the things you don't know and saying, okay, well, I just need to learn this one thing, and that'll fix a bunch of my problems. Yes, it's 1.5 hour test. These tests here you should be able to do these tests that I put in Moodle, these term tests. You should be able to do them in an 1.5 hours. Remember, exclude the correlation type questions. If you use Excel, Jorge, you can send them, sure. You can send them, but you'd have to send them as Excel because I won't be able to see formulas otherwise. I don't know if I can find much marks for you in Excel sheets though. So good night for now. Keep in touch. I can if there's some things outstanding that I haven't answered, email me and I'll try and address it in a future video. Well, I say future, but a video over the next few days. Work hard, work steady. When you work on the quizzes, try them without any aid, and then go through the answers. Remember, for these tests, they're not worked out solutions. If you want me to solve them, let me know. We didn't do enough of the DNS problems with the blocks and factors, elements of, or the components of an experiment. So if you have any questions about that, let me know. Good night. Good night, everybody.